Hello dear students, today we are going to discuss a new chapter which is related to the optics. The name of the chapter is Ray Optics and Optical Instruments. Students, you already learned some concepts related to the optics. Then what is by optics? Optics is nothing but it is the branch of physics in which we are dealing about light. That means under this optics we will learn some properties related to the light, phenomena related to the light and the nature of light. And we know that in this world light is essential for every living beings. Without light it is not possible to survive any living beings in this world. Sun is the main source of light and light is also a form of energy. The gravitational force will not affect the light because the light has enormous speed. That means light travels in an enormous speed. The speed of light is 3 into 10 to the power 8 meter per second. 3 into 10 to the power 8 meter per second in a vacuum medium. This is the maximum speed of the light in nature also. And light has no any mass. Light has two natures, that is particle nature and wave nature. In some of the cases light behaves as a particle and in some of the cases light behaves as a wave. But while explaining this concept, ray optics concept, here we are not considering any nature of light. Okay, so there are two theories to explain the nature of light. One theory is electromagnetic wave theory, which explains the wave nature of light, and another theory is there, that is the quantum theory, which explains the particle nature of light. So there is these are the some introduction part of the light and some basics related to the light. Then what do you mean by ray? Here we are using this chapter, we are using one term, that is nothing but the ray. Then what do you mean by ray? Ray is nothing but it is the path of the light along which the light travels. That means if I take one torch and if I switch on that torch, the light will come out from that torch, right? And we want to represent the path of light. To representing the path of light, we are using one term, that is nothing but ray. Then ray is nothing but it is a conventional way of representing the light or path of light. It is a path of light along which it travels. Then it is called as a ray of light. It is just a path of light. And how to represent it? Representing its path. To representing the path of light, we are using one straight line with arrow. Okay, so this is the path of the light. This line is representing the path of the light, and that arrow representing the direction of the light. That means in which direction the light is traveling. That is the meaning of ray. And another term we are using, that is nothing but beam. What is by beam of light? See, when I switch on the torch, there are so many paths for the light. Okay, that means we will observe there are so many rays when I switch on the torch. So that bundle of or collection of that rays are together called as a beam of light. So beam of light is nothing but a bundle of rays. Bundle of rays is called as a beam of light. Okay, so in light we are classified as two types, monochromatic light and another one is the composite light. That is classified on the basis of frequency and wavelength of light. So that on the basis of frequency and wavelength of light, the light is classified as monochromatic light and another one is the composite light. Then let us see what is by monochromatic light. Monochromatic light. monochromatic light means if the light has same frequency or wavelength, then that type of light is called as a monochromatic light. So monochromatic light is nothing but if the light has same wavelength and or frequency, then that type of light is called as a monochromatic light. So in this type of light we will observe same wavelength or same frequency for the light. And another type of the light is nothing but that is second one, composite light. And what is by composite light? If the light has different wavelength or frequency, then it is called as a composite light. So in this case, light does not have same kind of a wavelength or frequency. In this case, it has a different wavelength or frequency. So that it is called as a composite light. So on the basis of a frequency or wavelength, light is classified as one is the monochromatic light and another one is the composite light. Now let us discuss about the optical medium. We know that light can travel in a different medium. For example, light can travel in an air medium. Similarly, light can travel in water medium and also it can travel in a vacuum medium. So an optical medium is nothing but it is the medium through which light can travel. Then it is called as a optical medium. Optical medium is nothing but it is the medium through which light can travel. That means if the light moves in any medium or light can travel in any medium, then that type of medium is called as an optical medium. In the case of optical medium, there are two types of optical mediums. The first one is isotropic medium. And what is isotropic medium? Isotropic medium means if the light has same speed in all the directions, then that type of medium is called as isotropic medium. That means if the light has, it is the medium through which light has same speed in all directions. Then that type of medium is called as an isotropic medium. That means if I take rays of light, here if you observe, I am considering here 4 rays of light. If the speed of first ray of light is, assume that the speed of first ray of light is 3 into 10 to the power 8 meter per second, and in the case of second ray also, it has a 3 into 10 to the power 8 meter per second. Similarly, third ray also has a 3 into 10 to the power 8 meter per second, and fourth also 3 into 10 to the power 8 meter per second. If you observe here, see all the 4 rays of light have the different directions, right? And in all the different directions, the light has the same speed. Then then that type of medium is called as an isotropic medium. Okay, this is the one kind of a optical medium. And another type of the optical medium is an anisotropic medium. That is the second one, anisotropic medium. Anisotropic medium means it is a medium through which light has a different speed in different directions. Then that type of medium is called as an isotropic medium. Medium through which it is the medium through which light has different speed in different directions. That means speed of light is not the same in all the directions. Then that type of optical medium is called as an isotropic medium. So these are the two main types of optical medium. Now let us discuss one phenomena of light in which we observe in our day-to-day life. That is nothing but reflection of light. Reflection of light. The reflection of light we will observe commonly in our day-to-day life. Then what do you mean by reflection of light? So reflection of light is nothing but when a light is incident on a surface, then part of a light is turned back to the same medium. Then that type of phenomena of light is called as reflection of light. So reflection of light is nothing but when light incident on the surface, then a part of light turned back to the medium. Then that type of phenomena is called as a reflection of light. When a light is incident on a surface from one medium, then a part of light turned back to the same medium again. Then it is called as a reflection of light. That means, for example, if I hit one ball to the floor, then after hitting to the floor, that ball will again come back to up. That means these phenomena we will observe in a single medium. Here also like that, when we incident a light to the surface from one medium, after hitting to the surface, again it will turn back to the same medium. So that is the one of the phenomena we can see in the case of light, and that one called as a reflection of light. Let us see how we represent the reflection of light by using the rays. So here I am considering one surface. Assume that this board is one medium, and in that board I am considering one surface. Okay, and this surface has two faces. One is the upper face and the lower face. This upper face is nothing but this is the reflecting face, and lower face is nothing but it is the opaque or it is a non-reflecting face. If I incident a ray of light from this medium, so this is the medium, so I am incidenting ray of light like this. We are representing the ray of light, a light with air. When it hits to the surface, then light will again bounce back or turn back to the same medium. Okay, so I am incidented here. I am incidenting light from one medium, and after hitting to the surface, again it is bounces back or turned back to the same medium in which I incident the light. Okay, so this is nothing but the incident ray. This is the incident ray, and this ray is called as reflected ray. Reflected ray, and this surface is called as a reflecting surface. And here I am incidenting light with some angle. To know the angle, we are considering an normal. So normal is nothing but it is a line I am drawing. Here I am drawing one line which is perpendicular to the surface. That is called as a normal. That means that here I am considering one normal. This is the line I am drawing, and that line should be perpendicular to the surface, and that line should end to the point in which the incident light and the reflected light meet on that surface. Okay, so from that point I have to draw a normal, so that I can calculate the angle of incidence and angle of reflection. How to calculate the angle of incidence and angle of reflection? See, the angle between incident ray and normal, this is nothing but normal. Normal is nothing but it is the line which is perpendicular to the surface, and that line should be draw from the point in which the incident light and reflected incident ray and reflected ray meets. Okay, and that normal should be perpendicular to the surface. And incident angle is nothing but it is the angle between incident ray and normal. That means, so this is the angle of incident. Angle between the incident ray and normal is called as angle of incidence. So angle of incidence, angle of incidence I. Angle between incident ray and normal. Similarly, here I want to find the angle of reflection also. To know the angle of reflection, I am taking the angle between the normal and the reflected ray. Angle between the normal and reflected ray is nothing but this one. Okay, this is the angle of reflection R. So angle of reflection is nothing but angle of reflection, that is represented here R. That is the angle between normal and reflected ray. So this is the one of the common phenomena of light in which we are observing in our daily life. See here, so I am incidenting one ray of light to the surface. So after meeting to the surface, it is again turned back to the same medium, and that ray is called as a reflected ray. To know the angle of incidence and angle of reflection, I am drawing one normal. Normal should be drawn exactly perpendicular to the reflecting surface, and that should be taken from the point in which the reflected ray and incident ray meet on the surface. Okay, and angle of incidence is nothing but the angle between incident ray and normal, and angle of reflection is nothing but the angle between reflected ray and normal. Now let us discuss the laws of reflection. In the case of reflection, there are mainly two laws. Now let us see what is the first law of reflection. The first law of reflection tells that the angle of incidence of light is equal to the angle of incidence of light is equal to angle of reflection. This is the first law of reflection. See here, we already know that the meaning of reflection. if I incident a ray on the reflecting surface, after hitting to the reflecting surface, that incident ray will reflect or turn back to the medium, and that ray which is turned back to the medium is called as a reflected ray. And here we will observe there are two angles. One is the angle of incidence, that is I, another one is the angle of reflection. That means, see here, if I incident a light with some angle, for example, if I incident a light with some angle 30 degree to the reflecting surface, after if hitting to the reflecting surface, it will reflect with some angle, and that angle is a reflected angle, and that angle also should be 30 degree. So they are same. That means the angle of incidence I is equal to angle of reflection R. If it is 30 degree, it is also 30 degree. Suppose that if I incident a light with another angle, assume that this is an 60 degree. This is the angle of incidence. Then angle of reflection also 60 degree. Angle of incidence is equal to angle of reflection. That is the first law of reflection. And second law of reflection tells that, second law of reflection, the incident ray reflected ray and normal drawn all are lie in the same plane. That is the second law of reflection. The incident ray, reflected ray and normal drawn to the surface all are lying in the same plane. What is the meaning of that? See here, assume that this is an plane, this is one plane, and so this is one plane, and this plane has the reflecting surface. Okay, I am incidencing light to this surface in this plane, and after hitting to the reflecting surface, it bounces back like this. And if you observe here, the incident light and reflected light both are lying on this plane. And if I want to know the angle of incidence and angle of reflection, then I should draw a normal perpendicular to this surface, and that normal also lie in this plane. That means incident ray, reflected ray and normal drawn all are lying in this plane. That is the second law of reflection. That means all these three terms, that means incident ray, normal ray and reflected ray, all three are in the same plane. We will observe in the same plane. That is the second law of reflection. These are the two very important laws of reflection. Next concept is mirrors. In our day-to-day life, we are using the mirrors for different purpose. For example, we use the mirror to see our images. Also, we use the mirrors in the case of the vehicles. Then what do you mean by mirrors? A mirror is nothing but a smooth, well-polished surface which reflects almost all the light falling on it. Then it is called as a mirror. So mirror is nothing but a smooth, well-polished surface which reflects most of light falling on it. That is called as a mirror. Actually, mirror has there are two faces. For example, if I take this one, assume that this is a mirror. This mirror has two faces. This is the one of the front face, and this is the another one is the back face, and this face is considering as a reflecting surface, and the back face of this mirror is considering as a non-reflecting surface, and the back face of this mirror is painted and it is also called as opaque, and it is a non-reflecting surface. When I incident a light on this reflecting surface, the almost all of the light will reflect back from this surface, then it is called as a mirror. In the case of mirror, there are mainly two types. They are nothing but one is the plane mirror, and another one is the spherical mirror. In both the mirrors we can observe the reflection. Now let us see how the reflection takes place in the case of a plane mirror. Reflection in a plane mirror. A plane mirror is a mirror whose one side has a reflecting surface and another side has a non-reflecting surface. Then that type of a mirror is called as a plane mirror. Now let us see how the reflection takes place in the case of a plane mirror. Suppose that if I place any object in front of the plane mirror, for example, assume that this is one object and I am going to place this object in front of the plane mirror, then I will get the image of this object because of the reflection of light. When I place this object in front of the plane mirror, I will get the image of this object, and the size of that image is same as that of the size of the object, and also the size and also the height of the image is same as that of the height of the object. And another important thing that you should remember that the distance of the object from the mirror same as that of distance of the image from the mirror, so that we can tell that the image which we are getting in the case of a plane mirror is virtual and erect. Virtual and erect means the image size and object size is same, the distance of the object from the mirror and distance from the image from the mirror is same, and another thing is height of the object and height of the image also same, so that it is called as a virtual and erect image. So this is the reflection in the case of a plane mirror. And another thing you should remember that in the case of a plane mirror, we will observe the laterally shifted image. What is by laterally shifted image? Laterally shifted image means left side of the image, we will observe left side of the image in the right and the right side of the image in the left. That type of image is called as a laterally shifted image. This is also we will observe in the case of a plane mirror. What do you mean by spherical mirror? A spherical mirror is a part of a hollow sphere whose one side is reflecting and another side is opaque or non-reflecting. That type of mirror is called as a spherical mirror. So spherical mirror is nothing but a spherical mirror. It is a part of hollow sphere whose one side is reflecting and other is opaque. Opaque means it is a non-reflecting surface. So that is called as a spherical mirror. That means if I consider one sphere, assume that this is one sphere and the sphere has one center. The spherical mirror is nothing but it is the part of this hollow sphere. If I consider this is the one of the part of the sphere, then this one part is considered as one type of spherical mirror. Similarly, if I take another part of the hollow sphere, then this part is considered as another spherical mirror. Okay, so if I take this part, I will get like this. If I take another part, I will get like this. And both has a common center. Understood? So that type of mirrors are called as a spherical mirror. According to spherical mirror, it has one reflecting surface and other is the opaque. That means it has another surface as a non-reflecting surface. And in spherical mirrors, there are two types. They are nothing but types of spherical mirrors. There are two types of spherical mirrors. They are, first one is concave mirror. Concave mirror. And another one is the convex mirror. These are the two main types of the spherical mirror. One is the concave mirror and another one is the convex mirror. So that is about the spherical mirror. And in next class we will discuss how the reflection will takes place in the case of spherical mirrors and how the reflection takes place in the concave mirror and how the reflection takes place in the convex mirror. And also we will discuss some terms which is related to the concave mirror and convex mirror.